that might be a theme of my activities today is that it's wonderful to build and make things. There's a lot of mathematics involved when you have to sit down and use your hands, especially if you plan things out and you make a design first. And so one of the things that we might do is start by making a design. So let's suppose we want to make the one skeleton of a cube. That means all of its edges. So would somebody like to draw a picture of a cube on the blackboard while getting the balloons ready?
Okay, I'm clearly challenged.
It's already a challenging activity.
It's going to take me an hour to teach my kids all those things. Yeah, I totally covered your trunk.
That's a really nice colored out. Yeah, they are sometimes a challenge to tie. You give longer nails. What? That's a good question. It depends what we're going to make and how many things. If we get sort of consistent colors, maybe each of 4 different colors and another. And we've got a pretty good cube on the board. Marianne. Thank you, Marianne. So, here's a question. When you put balloons together, we can twist, well, here's a simple question. How many ends does a balloon have?
Depends on how many times you
But,
twist it.
well, no, end.
2.
Oh, that's true.
Sure. Now,
No, I said you-
if I do this, is this an end or is it the middle? By the end, what I mean is this and this. And so, we can do different configurations, like we can do this. Another configuration we can do is something like this. This is the way I might start with high school students, is just letting them think. I start with this problem for everyone. I found this is a really nice way to introduce a certain mathematical theorem that I'll tell you about. So, the question is, how many ends of balloons do you need right there?
Oh.
One more than you did.
That much. Less.
So, right in this region, how many ends of balloons?
3.
If we're looking for the minimal number of balloons to make that configuration, what's the minimal number of ends you need to make this configuration?
1, because you're connecting that in the middle. Or is that creating 2 now?
So, well, how many?
3.
So let's so. I'm afraid this might come across as condescending if you don't mean to. One of the things I want to do in order to show how we'd run this activity with 4-year-olds is I'd like to run it as if we're 4-year-olds.
You're modeling, it's okay, you're not condescending, it's modeling.
So, probably sitting in a circle, crisscross applesauce is a good way to go. So, come, let's get close around our little circle here. Yeah.
So in other
Or
words, on the
stand in, come and stand in a circle around me. One thing to do is, if you're going to work with 4-year-olds, make sure that you also have adults that are used to working with a daycare center, with the providers, some parents, extra bodies to them in A. So let's count the number of ends of balloons that appear in this circle. Right now, how many ends of balloons?
One.
Sweet. Here,
Zero.
high five.
I didn't say it.
Now, how many ends of balloons?
One.
Aha. Now, how many ends of balloons?
Zero.
Aha. So you see that now, how many ends of balloons?
Zero.
Uh-huh.
Those are
So,
middles.
you see how we're counting the ends of balloons in a certain region? So, let's come over here and count the ends of the balloons in this circle. Counting
One or three.
either one or three, sure. So if we're gonna do the smallest number, what's the smallest number of ends that
So
we
you
need?
have zero,
One.
and you have zero?
And you have zero. Well, let's look at this here a little bit. This is actually a key point. When I've got a balloon, when I'm putting it into a point, I can attach a point either at an end or in the middle. If I'm trying to make something that has 4 pieces out of it, I can do that. So I'll make something that has 6 pieces. I can do that. And in our circle, could I put this in the circle with the 0?
Yep.
Can I, with a circle, let's draw a circle up on the board, so this is our trash can. Can I do this with 0 ends of balloons? Uh-huh. Can I do this configuration with 0 ends of balloons?
Am I allowed to wrap and go backwards?
Sure,
So then I can do this.
but wait, is this?
No, leave that one alone. Wrap the gray one around it.
Wrap the gray one.
You could make a T like this.
So you're you have double.
Does that count?
Ah, so I would actually claim that that configuration looks, instead of like this, like this. It's a different configuration because it's got 2 edges coming down that one side. So it's got a total of, let's count. So this takes how many ends here? Let's do the minimal one.
Edges one.
Yeah.
What about here?
Same one.
So let's count now the ends of edges that are required for this.
One more. What was that one?
That would be eight.
Oh.
And so typically 4-year-olds would be doing 1, 2, 3, 4. You say 8. High school students will say 8. High school students, you can say, okay, if you have 8 ends of balloons, how many balloons do you need?
Four.
Uh-huh. And so this has 8 ends. I would not write this down with 4-year-olds. I would write it down with high school students. Therefore, 4 balloons. By the way, if I'm doing this with 4-year-olds, I would say, let's try to count how many balloons this means. And so, how many ends do I have in this first? Now how many?
Oops, sorry.
Now how many? Now
We should
how
do
many?
more. Okay.
Well,
Yeah.
you have a hungry 4-year-old.
Sorry, it's okay.
So,
No worries.
I was in
what
trouble
you
from
do
4-year-olds.
is see that the 4-year-olds figure out how many balloons they need to make. Once they figure out how many balloons, we sit down and we make a cube together. When I'm doing this with more advanced students, I will
That's
first,
good, right?
I will then hand out a handout, so middle school and up. And I still start with the cube problem. I found that this cube problem is a really great way to start this. people somehow can see the cube. In my first try, I did not have the dots in the middle at the beginning, the bullet saying make a cube, and the project did not work as well. So, let's now pretend for a second that we're high school students, or even middle school students. I want you to design your cube. You know that you're going to take 4 balloons to make your cube? So, how many edges does a balloon have? How many edges does a cube have? So a balloon has 12, a cube has 12 edges, and we're going to make a cube with 4 balloons, and so how many pieces do I need to fold each balloon into? How many segments do I need to get?
3.
Okay, so when you're actually doing the balloon,
That's okay.
if you start spinning near the knot, and then spin later on near the tail, that works well. If you twist near the tail first, then it makes it rigid, and you twist near the knot, it goes boom. So that's a good trick to know. So we're going to do something like twist here, we're going to twist here, and then we're going to have segments. We're going to get 4 things for 3 segments. Those are going to be the edges of the cube. But before we make a cube, I want you to design it. And so before anybody gets any balloons to play with, and this is a special, so the 4-year-olds blow up a bunch of balloons ahead of time, making sure you know how to make a dog, cat, a monkey, a rabbit, to be helpful. But would somebody like to draw a picture of a cube on the blackboard made with 3 balloons? So you have to color, well, 4 balloons, sorry. If somebody else likes to do the same, you can have competing models. Sure. So, the twists won't stay until they're bent or until you tie them. Oh yeah, you need 4 colors. One can be white.
Maybe this was a test.
In fact, even if you're not at the board, you might want to try this on paper. Try to design your balloon cube before you twist it. You have to pick a pattern. So we've got a pattern here. So in this pattern, Jennifer. In this pattern, it looks like Jennifer bent one in the shape of a U, bent another one in the shape of a U, another one in the shape of a U, and another one in the shape of a U. We're going to put the U's together and manage to blow it up. Any mathematical questions you can ask about this? I say here we've just made a cube and we've colored 4 different paths on the edges of the cube with 3 different colors. And so there is a way to do this. We've drawn one. Can you think of a mathematical question to go with it? Is that the only way? Yeah, asking questions is a wonderful thing to get people to do it. And so, is that the only way? Can you come up with another way to do it? So, has anybody found a different way besides the 4 U's to make the cube? So, once you find a way, I think I'll give you permission to make a cube, so. Find a different way, that'd be really rather cool. And so, if you're ready to make your cube, of course, it helps if you make the segments equal. And so 3 equal segments, so you can grab and twist a couple of times. And then, if you're going to do the next one, putting it in, you get similar skills. You can grab and twist. But the twists aren't going to hold until you put something else in them.
Yeah.
It helps if you have another person to hold part. And then if you just twist it together, like just twist the knot around 2 or 3 times around the twist.
You did?
That holds that segment.
So all we have to do is challenge.
Right.
And then if you just, another thing that will hold the balloons is once the bend
Oh, it's
them,
gonna go like
they
this.
will hold. So then here's another twist. And we're on our way. Has somebody figured out a different way of putting edges on balloons? Can you draw it on the board and show us so that people can take their choice?
So if I fold it in one, try doing it your way. I folded this one ready. Right.
Recommend I go to try it out.
Yeah, I got it.
Too funny,
It was helpful to have that, right?
right? Because it has to
Head,
Yeah.
yeah.
And you can do it with wires too?
This is
It
pretty
helps
good.
if you do it in teams and have maybe 2 people make one cube instead of 1 person make a cube. Unless you were
Have more than one.
very,
Now, let me see your picture.
So which way are you making it?
if you want to describe your pattern.
Yours is a
People
Z
see
too.
Kamala's pattern, it
Like
goes
this one.
in this
should I
line,
do that
in the x-axis direction, in the z-axis direction, and in the y-axis direction. Then it does the same thing with the green, the same thing with the white, and the same thing with the red.
This is the
So
first thing.
there are different
right?
patterns that you can
Tied
make,
together, they will work.
and that's kind of fluid.
That's perfect.
Just estimate. I
We
mean,
need
it's
that other balloon.
not that critical if you're off a little bit.
Okay, I'll hold it.
Right. Oh, you can't do that with the balloon?
Never had one of
Oh,
these before.
yeah, right, so yes, you can make a cube out of wires, but you can't make wires out of balloons, that's the problem. So you're stuck with U's and V's.
For 4-year-olds, this would be about it.
Yeah.
Have short attention span, right? I mean, sit down, ask how many ends, hold the ends around a circle, draw on chalk on the ground or on a piece of paper on the ground. Count the ends, the balloons that you need, count how many balloons you need, make a cube, and then you can start making puppy dogs. It really got, and it then
Oh, look at that.
engage in group of kids, you can ask them which shape they want you to make, and then you can ask them count how many balloons they need for each shape, which is an interesting mathematical question. And it's one that you can figure out exactly the same way you figured out the number of balloons that we needed for our balloon cube.
The foreign, yeah. So this is a Z.
Another
A Z. we add that on the corner? Alright. And then it's gonna go this way.
Yes, it's like balloon origami. And of course, as soon as you realize that you can make a cube out of balloons, you realize that balloons are cheaper than a polygon.
They are a lot.
And you can use them in very much the same way.
Convince 4 balloons is minimal.
You know, at least ours was used. Then it would have to be,
The other side.
it was new. It was blown up like a shot across the room. I said,
You were allowed to go over it. Get away with one.
Yeah, that's good.
I'm not quite sure mathematically.
Why you bought
They were so Paul, or not Paul, but he was focusing on the performance. But what's the minimum limit or
well, why did you got another mathematical
said like
So
one?
what you go with popcorn, but then what the minimum number is that you could
Really, you could
Yeah,
one
no, I
whole
mean,
you made the square and then came down.
I would like to.
Oh, I guess that's still has one end though. So it's one, it's the beginning.
Time off and then you try it.
Okay, thanks, Fred.
mathematical question for, say, middle school students of, say, design it before you make it. Because that is an honest math. You have to think. And we came up with 2 different designs. The U and the V. And you should look at them and try to
Then the
find
question
those
is,
designs here.
how many people
And
can
figure it out. So,
That would be a 4-year-old.
puppies, kitties, dogs,
Oh, it looks great.
You're doing
in fact, this, yeah, so the dog is this, nose. If you just Google balloon animals, you can find great videos of people showing you how to make balloon animals. But in fact, one of the things to do is,
So the end always goes to the middle of another one, so I need to cut. I need the ends here, we have to do this one here. And then here. So really good, right? The other one would have to go to there.
so, is, the students might ask you to make things, like they might ask you to make a dog on a leash, or they might ask you to make a cat, or they might ask you to make a rabbit. So you draw a picture of the animal that you're going to make, and if they're really going to do math and you want to do more, you just ask them, okay, so how many balloons is this one going to take? Let's count the ends. And they can figure that out. Actually, if you look at the handout, there's a couple of different directions we can go. One thing that you can do, which you can actually get divergence. With a group of high school students, they say, hey, start looking at the problems, and we got different students working on different problems. One thing we got a big group of students working on that a lot of people were interested in was let's make something big with balloons. And so there's a pattern here on the back to give you one example of a snug cube cathedral. And it's made out of a bunch of units that you then tie together. And so the question is, how many units, how many balloons do you need to make one of those balloon units on the back? And another question is, if you're going to make this balloon unit on the back, where do you start? Where do you put the end of a balloon? And this actually gets us to one of the theorems. Let's look at that.
Yeah, it looks like it's one balloon.
Each unit is supposed to be one balloon here. But let's verify that we can do it with one balloon by counting the ends. If you're looking at the minimal number of ends, what's the minimum number of ends you need in here? What about here? What about here? What about here? Holding up pencils or pens with the really little kids helps them see the ends and count. Right there, you recognize something that you could probably give this to your colleague, and your colleague might not get it on the first chance. You say, let's imagine that you start on this diagram, and you're going to start at some point and try to draw a path that goes across each edge exactly once. And so, if you were going to do that, where should you start? You have to start at one of the ones beside. If you start up here, this means I'm putting an end of the line segment here. Oh no, I have to have another end here and another end here. I'd have to have at least 3 ends, so how many balloons would I have to have if I started here? If I'm having 3 ends, can I do that with 1 balloon? So how many balloons would it take if I had started here? It would take at least 2, and so that would mean that I'd have to lift my pencil off the paper. In fact, there's another puzzle. In fact, if you look at the question, there's this 7 bridges of Königsberg, where you draw a bunch of bridges, and the question is, can you walk a path around the city where you walk across each bridge exactly once? I've tried to explain this to students at different times in classes, and far and away the most successful way I've had is to start with the 2. Somehow I found people can see that this corner takes 1 end of 1 balloon, and then they go on, and they can see the pattern of where you have to have the ends, so then they can count the ends in the graph for the bridges of Königsberg, and figure out that can't quite be done. You could also just start randomly drawing graphs, which I'll show you another way to do that in a second. But since you know that this one, you have to start here and end here, how many segments are there? It's 5 segments. So if you want to build one of these units, so if a group of people want to build a big thing out of balloons in this exercise, my suggestion is that we really do color code. It doesn't have to be the same 4 colors that we're showing here, but having 4 units of one color, 4 units of a different color will really make it easier. And so you might decide, hey, let's start going with green. We have green balloons or so we've got purple started, we've got blue started, and so we can start making these units. And if you make 4 purples, 4 blues, 4 of something else, then we'll be off and running.
What's the other color? Is it clear? Well,
Yeah.
So it's a cube you can drive.
I have it here.
Yeah.
So let's pick the samples up when we get them. We've got a blue.
Yeah.
That blue.
Zones, polydromes, and
We've got a purple. They're all like this.
yeah.
Paul needs one. I'll take some.
We have another unit made up. Looks like we're doing zero. Maybe not.
Too eager.
We're making a half unit. To make a bigger
How many of each?
we need a total of 4 of each color. I think that's
So
it.
we can make some
How much of this thing do you need on there?
I know,
Well, I imagine
that needs to be longer and is what my measurement.
This is no tires.
Remember we did that.
Oh, no, we have one.
How big is this thing? Is it one side? Is it below? twist
Now
it.
I don't know, it's gonna take 4 of each of these unit pieces to make one.
So we can use that other open one if we can use it.
Fold the 3 again?
No, it's that shape, it's gonna have 5.
So we're supposed to leave a little bit of.
Roll up a little bit, correct.
Yeah.
You want them in each of the colors so you can follow, the building with.
Yeah, we gotta figure out how big
Okay.
it is.
So from your knuckle to your, okay. You think that's too small?
We're making a 5 in order to keep unit. Mine are way smaller than yours.
Yeah, it doesn't stay together.
Oh, that's the problem, we don't know what they're. So it has how many, 1, 2, 3, 4, 5. There's 1, 2, 3, so you have to have,
Now I'll get some other ones.
you have to divide it into 5. And we learned how to do that paper folding.
I know, right? Yeah.
So I don't know if you want to iterate. I don't think the piece will work.
Yeah, so here's the other
What other color imagery, yellow one? 3 yellows?
You need 4 colors?
We need 4 of each type, 4 colors. We've now got the colors. We've got a yellow, a blue, a purple, a clear. What? No, we need more. The colors we need are, do one out of a clear one. Do one out of clear one, somebody else. Oh.
I got this.
How do you get,
Mine's really
Twist
lopsided.
around.
It's lopsided. They're all colorful. We gotta do the iteration like this.
If you've got one that's made, you can use it as a model to get the
I'm happy with this.
And still the air back on there. Circle 11. So teach 11, circle 11.
got 3 blue,
Yeah.
purple. So,
Yeah, you just gotta decide.
by the way, you'll see 4-year-olds walking around with
Okay,
I
we
don't
need a
like it.
picture.
I might not be a 4.
You definitely need a picture of this.
My head should go in.
Yeah.
There we go. Robot.
Joy. Yeah. Yeah.
I know, that's.
Wait, where's our documentation for the web?
Here we go.
So, if I want to look like a
Put them on your leg.
Get one on each leg.
One on each leg. One on each leg.
All right.
All right.
Wait,
So,
one more with the fuel on his head.
you go ahead.
Oh dear.
This is also the end of the week.
Okay. Party.
This is just absolutely.
So,
Orientation of all the others. I'm putting this one in first.
Oh my gosh, this one is just so off.
yeah.
What about this one?
Look, the orientation is completely wrong.
Oh, that is the wrong number of segments.
No, it's fine.
The center is just so long.
We can turn you this way, it's short.
Oh, I see, yeah.
It's like, that'll mess with the plan.
You find about, if I had 5 segments, you could look up there.
Me too.
And then you.
I myself is going to blow up. I'm not.
So,
No, you should use this because you get a, you know, like a bubble in your jaw, you know, it hurts.
with the high
Don't
school
get
students,
scared.
I try to get them to start answering some of the math questions on the page. Same thing with middle school. With
Is this the right length?
4-year-olds, I come back another day because by the time they made a balloon tube, the balloon puppy, they're so wired and happy, it's just a big party, and they just have fun playing with them. They're very excited.
That work?
They're so excited that they want to see you and see what you're going to do next. So the next day you can continue the puppy theme. And so with puppies, as you know, like sniffing out their neighborhood, they like ice cream, cats, squirrels, bones. And so you give them a name. And the puppy wants to see everything. The owner doesn't want to walk too much. And so what you have to do is find a way to walk on every sidewalk exactly once. And so where do you start and where do you stop? Now this is a question, when you make it at this level of complexity, that the fellow teachers will not be able to do this the first time. If you do it right, your 4-year-olds will. And that's kind of cool. Though actually, that claim is not quite true. 4-year-olds have trouble abstracting from the balloon to the maze. Yeah, when you give them hints about the ends, they can kind of get it at the end, but they have trouble.
What's happened?
This is all going to be on the web, you know, all the handouts. And so, you're welcome. So, certainly your first graders, though, if you hand it to them, have 2 for each student. You first hand it to them, and they won't see balloons in this drawing, and they'll try it, and they won't get it right, and they'll go, I can't do it. 4-year-olds have trouble getting the lines and pens. In kindergarten, you practice doing that. First grader can color with crayons when following the sidewalk. But the first time, they're not going to think about the balloons. So then you do the same ends in the circle that you did on the first day. When you draw the circle, and you say, how many ends in the circle now? How many ends in this configuration? How many ends in this configuration, where you hold up circles, which actually works a lot better with pencil, pens, chalk. So how many ends do you see in this configuration in the middle? How many do you see here? You can cross and put like that, and that's when you count the number of ends. But once they recognize that the vertices of odd valence all have to have at least 1 end, then they recognize that on this graph, anything that looks like an X doesn't have to have an end. So if you're going to study ends and do it with a minimal path, forget all the X's, and now you can solve the problem and hopefully see how this relates to balloons. Are there questions? Do people get how the maze problem relates to the balloons?
But I have a question.
Yes.
So it's an even odd.
Yes.
So there's 5 people.
Yes. So how many ends does the 5 take? let's try to make it fun. Let's grab some random balloons.
Okay, that's
So,
totally my deck.
here's-
Okay.
I'll hold them up in a nice circle.
This is my first one.
I have a classroom management question, which we all probably have, which is,
I can solve that.
How do you not get
yeah, well, it's the same problem, it's what I call the hat problem with zones. How do you get, I mean, you're gonna have at least some of the time people are just gonna wanna make a hat out of zones, or, you know, a robot shield out of balloons. How do you get them to not, how do you get the percentage down from like 99% hats down to 5% or something?
And you go, the minute you send the first pull out for 5 minutes, you have to sit and not touch it for 5 minutes. It's not really 5 minutes, because they don't know 5 minutes is.
But how do you do that with college students?
There you're on your own.
But,
Well,
yeah, no, but,
Is it polyhedra?
what?
Is it a hat? Is it polyhedra?
Yeah, but I mean, the general problem is that it's just fun playing with balloons, and it's hard to, it's fun to pop them, it's fun to make them fly around the room, make them
Make
nice
swords.
sound, yeah.
Right, lightsabers.
Where like 5 minutes before class they get to play? And so
Yeah.
if they get to class early, they get to play, and if they
Uh-huh.
don't, they can't?
Yeah.
Opposite order is better. My suggestion in actually doing this is you first get them to count, and you do the drawings, and you show the sticks, and you describe things, then you make something with the balloons, and then depending on the audience, after you make the cube, the 4-year-olds, you're done.
Yeah, yeah.
With the high school students, you show them that, hey, you've made a cube, now we can make something really big. Would you like to make a big polyhedra? So get in, and you can keep them going for about an hour, making something big.
Maybe you have like a team challenge of the biggest thing you can make in the hour or something like that. That's one of the ways I found to get kids together is to see which team can do the biggest.
So another comment about this is you don't have to do this all at once. You can keep extending it. You can bring this in.
How long do these last physically?
Well, I did the cubes with 4-year-olds for about an hour. I think I did 10 minutes of building the first cube and 5 minutes of talking and 45 minutes of making puppies and...
No, I mean, how, do these last for days?
The actual things that you build. They actually last for maybe a couple days. They really start fading after 3 days.
So having a camera is important.
But that's actually an advantage. You know what? Do we want to tie together something big? Something big? Oh, we need some more clear ones. We've got the purples, the blues. We've got...
Here's another one. Oh, some people are
We have 2 more clear ones. We've got up on the blackboard.
They're already started
What's
behind you. Here's one, but it's kind of small.
Oh, you're already... so look
make good
very
ideas.
carefully at the patterns. We're gonna put this together. So,
We need to have 5 at each workshop.
That makes sense. If we unwrapped it.
Right, if we built them in,
We've got 1, 2, 3. This makes sense that you can go like this. You just have to take this one here and try it. Like this. Is that not right?
well, that, if you did that, then what do you have there? You have,
I have some
we
red.
have 1, 2, 3, 4.
You've got 5 edges. Are you saying?
I want 5 triangles meeting at each vertex.
Okay, 5 triangles, not 5 edges.
They like to work with
Right.
that.
Well, we'd have the right number of, we'd have the right number of, all we would need is 10 of these objects, because we need 20 triangles. But it's the weaving that I don't understand. Yeah. But what about even making a tetrahedron?
Even adults just tie, yeah. So there's a good point with first graders. Can first graders blow up balloons? Blow up with a bicycle pump or with a balloon pump? Yes. Tie a knot? No. And so with this type of activity, you get so much adrenaline in the room and bouncing. Having extra adults on hand will help. They can help blow up balloons.
But that's not the same as this, yeah. Because in fact, all we do, see, this is the tetrahedron.
Yes.
Have a bunch so that there's problems that not getting help right away, and this is on, you have to get them some.
And the other thing is when you come into the room, bring a stack of balloons that are blown up in a garbage bag. Put it in the corner of the room. You don't want kids to see the balloons when you're starting top math. If they see, so do the ends with pens or sticks or something else. Once they see the balloons,
so we already have 5 edges here. So all you need is one sausage, like this sausage here.
There's another thing that I'd like to point out about the maze.
Right, and that's the thing, if you were going to make an icosahedron, right? An icosahedron has 20 faces, and it has 20 faces, and it has 30 edges. Yeah, because there's 12 vertices. And so if you made, and this has 5 edges, and if you had 10 of them, you'd have 50 edges. These are not, these are not the right building blocks for an icosahedron. You can make an icosahedron out of balloons, right? But then you wouldn't use these as
You
your
make
tiles.
any graph out of balloons.
Right.
There's one balloon for each end.
Right.
And then you can figure out the minimal balloon number.
Right, but that's what I mean, because 10 of these would give you the faces, for an icosahedron, but it would give you too many edges.
But the point is to use less than 10 and put together to make triangles out of the other.
Right, but it's like,
you have to design it before you make it.
right, absolutely, yeah. But that, and I wonder what, whether you'd want to use this as your main building block. You might have some of these. Because the interesting question is, can it be made all with the same unit? Yeah. Yeah, these are neat questions.
Questions to answer.
Yeah.
Put down. So I put some on the handout, but you can make it on your own and ask. So speaking of making up questions, one of the things we don't teach. So.
Oh, the vertex twisting, yeah.
Clap once if you can hear me. Clap twice if you can hear me. Clap 3 times if you can hear me. All right. So just a brief introduction, intermission in the play. So for the first graders, I said, here's a maze. Now play with the maze. That's a second day, it's a 10-minute activity on another day after you do the balloons. Relate it back to the balloons, and they see what the result is. Then the next time you come in, maybe a couple days later, instead of you giving them a maze, you tell them to design a maze. It can be dragons, it can be sharks, it can be whatever they want, connecting up paths. And then start out with 2 vertices that have just one balloon end in them. Let them figure out where the start and stop are going to be. And then have them hide the start and stop by making a lot of other intersections that use no ends. Put those other intersections all over, then draw their sidewalks or their tunnels through the lava tubes or whatever they're drawing, and then draw the little figures, and then that's the puzzle that they've drawn, which even their mom or dad would have trouble if they don't know this theorem, and yet they know it, and so they have this sense of, aha, I can make puzzles that mommy and daddy can't, but I can.
Do you want to show us
instead of a pencil, because it automatically makes the lines happen.
I didn't show you that, but that's a great idea.
It totally works. I don't remember.
A highlighter in a maze?
Yeah, like.
No, yeah, well, if you start with the highlighter, because the pixels might not necessarily be able to make the two lines.
Awesome.
A highlighter is actually,
Okay,
I can use it for one.
I'm being stumped by a
True,
maze
yeah.
for a first
And then you
grade.
just do the in and out
But
with
the
the
point is, you really stumped unless you realize where you have to start and where you have to
Oh, to build the tetrahedron.
And now,
Are you making it with one? You can make,
And I'm just gonna get back
there
there.
is a second one?
well, you can get back out.
They're
So,
both round, round
you
Z's.
have to start somewhere that's up.
Look at that.
Now, so what
There
I
you go.
if you stop there, if you
A
started
single
to stop
tetrahedron.
and
Right.
I'm still going back to the Kongsberg office.
Oh, look at that.
If I start and stop
This
at
is
the
great,
same
yeah.
place like that, what's the
Uh-huh.
valence of that vertex?
Did you draw a
How many
picture
segments
before you did it, or you just?
even or off?
Very good.
Well, I thought, well, each one of the three, so you got.
Wait.
Oh, so you have
Zero one,
4
two.
ends, so you.
Right, there's zero ends, basically, I put the two ends together and kind of make them live. So if it's even, you don't necessarily, you don't have to have.
So let's
it
think
in
about
that
an
when you
icosahedron.
invert that. So I started to
So-
start at
Icosahedron,
it has to
it
start
has
at
12
an end.
vertices.
Oh, I thought it was right.
No, this problem, you just have to follow every sidewalk and exactly once. So if you start at the fire
Therefore,
hydrant, where
it
you
has
gotta
to
end?
have a minimum of 6
The other
balloons,
Which is,
right?
yes.
Dodecahedron?
I was trying to compact this and go
You
back.
have at
is
each
that
vertex,
possible?
there's 5 ends.
Because one end has to be here and one end has to be
So
here.
that means you have to have an end each one, so
You could go like that.
12 vertices. Why not 6?
Oh, 6 balloons, that's right. Yeah,
And so,
so every point.
but so here's a way to, yeah, way to, do we need 30 edges?
Each one has to have 5 pieces.
Yeah, we can draw on a blank piece of paper a graph next of an icosahedron. And then we can design, just a graph that, but, yeah, an open graph. So, yeah.
Yeah.
An icosahedron, we probably have one right here. Maybe we have one right here.
20-sided?
Yeah. Is there an icosahedron? No, but there's here's an icosahedron, it's inside.
You like this one? It's
Maybe we can make a dodecahedron too, yeah. Or we could do a dodecahedron, but icosahedron. So, yeah. So an
You can still ask the
icosahedron,
question.
it's inside. Yeah. So, blank paper, could you use a blank piece of graph? Okay, a graph paper, yeah, so
Just to start one.
and you have, that's, your,
Some of it's nice, even like you said, some of it is
yeah,
one
that's
is
your
animals,
base.
but even when you
And then,
start out giving them
you're gonna have,
certain numbers and make whatever you want, just for the little kids to get that out of their system before you go to the cube. I work with little enough to 12 first graders that really like to do things.
I found like working from most attention to least attention for me has worked best. And so first talking and using sticks,
So 1,
then
2,
the cube,
3, 4,
then the
5.
freeform.
Oh, okay, so
And
you
then,
cube and then freeform, okay.
Yes, because after you start freeform, you're getting too many calls for too much imagination. Let's make that, let's make this other thing. So in fact, the
Right, so it's 1, 2,
imagination, after they
3,
have
4, 5.
and
And this should be right, 1, 2, 3, 4,
draw a
5, 6,
picture of it
7.
first. Or here's a picture of things off the internet, of various balloon animals and constructions. How many balloons will this one take?
Right.
How many balloons will this one take? Find the ends and how many balloons it will take. Go get the balloons. You wanna build a house? You wanna build a shark? You wanna build, let's draw a picture of it, the dot and the line. And now, how many balloons will it take? That is the question of the day. And you just So they have to answer that question and then draw a picture of which color balloon goes where. Then they get the balloons and get to make it. And then go. That way you're.
Probably better, because they're teaching them to model how to twist the balloons and how to situate them together. They get a feel for it with one project, one end in mind. So that is a really good idea before they go off and make, have like 20 balloons and things.
Yeah. Yeah.
I like it.
Yeah.
That's my suggestion.
And so you've done it with your daughter's class?
I did it with my daughter's class. I've done it with the middle
each of
school
these-
group, and I did it with the high school.
Great,
I'll probably do it with my son's class at some point. He'll be in second grade in the fall.
So these sides are here, so and that giant cube, what else? So you
And anything made with, anything made with sticks
Oh, yeah,
connected
see,
together
what
at
color do
the
you
end,
Clear.
you can,
Clear.
there's one right there.
Thank you. Actually, we have it.
Okay, one pop, really easy.
Maybe we should use it.
He's right.
Yeah. Yes, so, yeah.
Oh, the one was a U design, where there were U shapes, and one was a Z shape. Here, this is what the Z shape
Right,
looks
so,
like.
so that will be 20.
Yeah, okay.
So,
Kind of the outside, that's just, I mean, that's kind of.
right, yeah,
So this share, people share the slide, is shared amongst all of them?
that's right, that's all one balloon. Right.
Good idea.
It's really, this is, graph paper's bad for this. Blank paper is what you need. Oh, you have a, here, keep this, be careful with this stack, Chris, I'm worried about.
That is
Oh, so this, so is that, there's an icosahedral, these are all different icosahedral graphs, right?
Yeah.
Always nice.
Same connectivity though.
Right.
Well, I mean,
That's my question, is like.
They're hard to see. This is basically what we did, right? Yeah, this is the most useful. That's the most useful one. Let's recap that.
Everyone, I'm gonna assume, like everyone.
Right.
If we have
You'll be in charge of the balloon day.
Most likely, yeah. Yeah.
Day too.
Right, so we should do something where you have a five-sicle.
Let's make 6 different colors. Same side. That was my mistake. Same side. Let's make 6 different sides.
And then we have structure. We have things that are built like that.
I mean, just my intuition would say.
The how it looks, like they ask, what shape will it be? And they see where? No, there's a square bubble. When you blow a bubble, it always becomes a tree or hill.
So if this is segment 1,
What makes
I would say that this is a bubble technology, this is a bubble, maker bubble, this is a center road, meaning what a bubble. And this should probably be down for, you do 5, this is a bubble, together this is a swimming pool. You want to be that my intuition would be like that. So there's this one here. Lift it up, and they're inside a bubble.
See, I wanted to draw it on the
They have a
lens.
station where.
Should be good.
Reference that picture there.
Especially before. Like you did this a week before. Something like my 21st.
puppies! So,
You can have like a graph theory.
alright, now, there you go.